Welcome to our channel. Today, we're embarking on a journey to explore the cosmic wonders of the universe. But more importantly, we're going to shatter some widely held misconceptions about space. Those myths and inaccuracies that have wormed their way into our collective understanding. Get ready to have your mind blown as we delve into the depths of space and uncover the truth. From the seemingly innocuous color of our sun, to the persistent myth of a silent cosmos, we'll be your guides through the vast expanse of space, armed with scientific evidence and a healthy dose of skepticism. Prepare to challenge your assumptions, embrace the wonders of the cosmos, and gain a deeper understanding of the universe and our place within it. So, fasten your seatbelts and get ready for an exhilarating ride through the cosmos as we debunk 13 pervasive lies you've been told about space. Some say the American flag waving in the windless lunar landscape is proof that it was all a Hollywood production. But think about it, that wave is just the flag settling after being unfurled. No wind, just physics. And those shadows, supposedly cast by studio lights, they're not parallel because the lunar surface isn't flat, creating the illusion of inconsistent shadows. It's a matter of perspective, not fakery. Then there's the lack of stars in the photographs. Well, the lunar surface bathed in sunlight was brightly lit during the landings. Cameras set for those conditions wouldn't pick up faint stars in the background. Basic photography, folks. The Van Allen radiation belts, a supposed death trap for astronauts. NASA planned the missions meticulously, ensuring the astronauts passed through the belts quickly, minimizing exposure. Safety first, even in space. The idea of a completely silent cosmos might seem logical given the vacuum of space, but here's the thing, sound doesn't travel through a vacuum, that's true, but space isn't entirely empty. There are whispers of interstellar gas and dust, faint remnants of exploded stars and the echoes of cosmic events. These, while not audible to our ears, can be detected by specialized instruments on spacecraft. These instruments pick up vibrations, electromagnetic waves and charged particles, which scientists then translate into sound waves we can hear. And let me tell you, these sounds are nothing short of awe-inspiring. From the eerie hum of pulsars to the roar of solar flares, the universe is alive with a breathtaking symphony of sound, waiting to be heard by those who know how to listen. Our sun, that blazing ball of fire in the sky, seems undeniably yellow, right? Well, here's the cosmic twist, the sun is actually white. The yellow hue we perceive is due to our atmosphere playing tricks on our eyes. As sunlight passes through the Earth's atmosphere, the shorter blue wavelengths are scattered more than the longer yellow and red wavelengths. This scattering effect is why the sky appears blue. When we look at the sun directly, especially at sunrise and sunset, we're seeing the light that hasn't been scattered as much, resulting in the orange and red hues we associate with those times of day. But if you were to venture into space, beyond the interference of our atmosphere, you'd see the sun in all its glory, a brilliant blazing white star. Chapter 4. Black holes. Cosmic gluttons, not vacuum cleaners. Black holes, those enigmatic objects with gravitational pulls so strong that not even light can escape, are often depicted as cosmic vacuum cleaners, sucking up everything in their path. But here's the thing. Black holes don't actually suck. Their immense gravity warps the fabric of space-time around them, creating an inescapable gravitational well. Objects caught in this well are drawn towards the black hole, but not in a vacuum-like suction. It's more like falling into a deep pit. Once you cross the event horizon, there's no turning back. However, black holes are messy eaters. As matter spirals into a black hole, it forms an accretion disk, a swirling disk of superheated gas and dust that emits intense radiation. Chapter 5. The Great Wall of China, Lost in Space. The claim that the Great Wall of China is the only human-made structure visible from space is a persistent myth that just won't quit. It's a romantic notion, but let's face it, space is vast, and the Great Wall, while impressive, is relatively thin. From low Earth orbit, where the International Space Station resides, astronauts can spot cities, major highways, and even large agricultural fields. The Great Wall, however, blends in too well with its surroundings. Even from the Moon, a whopping 238,900 miles away, the Earth appears as a small blue marble. Discerning individual structures on the surface, even something as grand as the Great Wall, is simply impossible from that distance. So, while the Great Wall remains an architectural marvel, it's not a cosmic landmark visible from space. Chapter 6. Space, a matter of temperature, or lack thereof. Space is often portrayed as frigidly cold, and it's true that the vacuum of space can be incredibly chilly, but it's not as simple as saying space is cold. You see, temperature is a measure of the average kinetic energy of particles. In space, there are so few particles and they are so spread out that they don't collide frequently enough to transfer heat. So while an object in space might radiate heat away and eventually become very cold, the vacuum itself doesn't have a temperature in the traditional sense. In fact, in direct sunlight, objects in space can actually get quite hot. The International Space Station, for example, has to constantly regulate its temperature to avoid overheating. So, the next time you hear someone say space is cold, remember that it's a bit more nuanced than that. Chapter 7. Tears in Space, a zero-gravity sob story. Can you cry in space? Absolutely. Our tear ducts work just fine in zero gravity. However, there's a catch. Tears don't flow down your face like they do on Earth. Gravity, or the lack thereof, changes everything. Instead of cascading down your cheeks, tears in space clump together, forming watery spheres that cling to your eyes. It's like having tiny shimmering contact lenses. Imagine crying in space. Your tears, instead of streaming down your face, would simply pool beneath your eyelids, creating a watery barrier between you and the cosmos. Astronauts have reported that these tear bubbles can even sting a bit if they grow large enough. So, while crying in space is possible, it's definitely not as cathartic as it is on Earth. Chapter 8. The Moon's Not-So-Dark Side. The term dark side of the moon is a misnomer, a relic of our earthbound perspective. It's easy to see why we might think that one side of the moon is perpetually shrouded in darkness. After all, we always see the same face. But here's the thing. The moon is tidally locked to Earth, meaning it rotates on its axis at the same rate it orbits our planet. This synchronous rotation is why we only ever see one side. However, the moon, like Earth, experiences day and night cycles as it orbits the sun. So, while one side of the moon faces us, both sides receive equal amounts of sunlight over the course of a lunar month. There's no perpetually dark side of the moon, just a side that's hidden from our view. Chapter 9. Space Travel. The Final Frontier. For everyone? For decades, space travel has been the exclusive domain of highly trained astronauts, a select few who dared to venture beyond Earth's embrace. But the landscape of space exploration is changing, and the dream of experiencing the cosmos firsthand is becoming more attainable. Private companies like SpaceX, Blue Origin, and Virgin Galactic are pioneering a new era of space tourism, making it possible for civilians to experience the wonders of space travel. While the cost of a ticket to space is still prohibitively expensive for most, the trend is clear. Prices are coming down, and access is expanding. Suborbital flights, offering a taste of weightlessness and breathtaking views of Earth, are already within reach for some. As technology advances and the space tourism industry matures, we can expect to see even more affordable and accessible options for space travel in the not-too-distant future. Chapter 10. Flat Earth. Debunking the undebunkable. In an age of scientific advancement, it's, well, baffling that the idea of a flat Earth persists. But alas, some cling to this archaic notion, despite overwhelming evidence to the contrary. Let's start with the obvious: ships disappearing hull first over the horizon. This phenomenon is a direct result of Earth's curvature, and if our planet were flat, we'd see the entire ship shrink into the distance. Then there's the matter of time zones. The Earth's rotation and its spherical shape create distinct time zones, with different parts of the planet experiencing daylight and darkness at different times. And let's not forget about the countless images of Earth taken from space clearly showing our planet's spherical shape. Unless you believe in a massive conspiracy involving every space agency in the world, the evidence is irrefutable. Chapter 11. Space Without a Suit. Not as explosive as you think. Hollywood loves to depict the gruesome demise of astronauts exposed to the vacuum of space, instantaneous explosions, bodies inflating like balloons, and blood boiling in their veins. The reality, while still deadly, is far less dramatic. The human body is more resilient than you might think. Exposure to space wouldn't cause you to explode, but it would lead to a rapid loss of consciousness due to the lack of oxygen. You wouldn't freeze instantly either. Without air to transfer heat away from your body, you'd actually stay warm for a surprisingly long time. The biggest danger in space is the lack of air pressure. Without the Earth's atmospheric pressure to counteract the internal pressure of your body, your tissues would begin to swell, but not to the point of bursting. Chapter 12. The sun's long goodbye, no need to panic, yet. The sun, our life-giving star, won't last forever. Like all stars, it has a life cycle, and one day it will reach the end of its stellar journey. But before you panic, we're talking billions of years in the future. The sun is currently in its main sequence, happily fusing hydrogen into helium in its core. This process releases the energy that sustains life on Earth and keeps our star shining brightly. In about 5 billion years, the sun will exhaust its hydrogen fuel and begin to expand into a red giant. This expansion will engulf the inner planets, including Earth, rendering our home planet uninhabitable. Eventually, the sun will shed its outer layers, leaving behind a dense core known as a white dwarf, which will slowly cool over trillions of years. So, while the sun's demise is inevitable, it's not something we need to lose sleep over just yet. Chapter 13. Alien Visitors. Where's the evidence? The idea of extraterrestrial life, of intelligent beings from other worlds, has captivated humanity for centuries. But while the universe is vast and the possibilities seemingly endless, concrete evidence of alien visitation remains elusive. Sure, there have been countless reported sightings of UFOs, grainy photos, and anecdotal accounts of alien encounters, but upon closer examination these claims often unravel, revealing more earthly explanations, weather phenomena, misidentified aircraft, or hoaxes. The scientific community remains open to the possibility of extraterrestrial life, and there are ongoing efforts to search for signs of life beyond Earth, from listening for radio signals from distant civilizations to searching for habitable exoplanets. However, extraordinary claims require extraordinary evidence, and as of yet, we have not found any credible evidence to support the notion that aliens have visited Earth. Outro: keep exploring the cosmos. Thanks for watching. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more fascinating space content.